Okay, so inverse functions. So we have a function here, and we need to find the inverse from it, which would be written as f at x to the power of negative 1. So if they ever give you a question where they've given you some function is equal to some equation, and they ask for this, they're looking for the inverse, which means they want you to switch essentially the x values and the y value. But in this case, we have two x values, and in order to do this easily, we want to have one of each variable. So you kind of replace your f at x with the idea of a y variable. Still write the exact same function. But again, we only want to have one x value in here. So the first thing I need to do is kind of figure out what type of function this is and how I can get x by itself. I know because it's the power of 2, it's quadratic, so it's some type of parabola when we graph it. And I know I can get a single x variable in a parabola if I put it into vertex form, which is completing the square, or there's like formulas to do it. However you are taught to do it, you just have to go through that process. So in this case, we're going to complete the square here to figure this out. Okay, so to complete the square, the first step is to usually divide the very first two terms by the coefficient in front of x. In other words, you want x to have no number or the number 1 in front of it. So we're going to common factor out the value of 3. So we'll get y is equal to 3. And then you have x squared plus 36. That's going to be 1, 2, 12. Okay, not the nicest number. I could have chosen something nicer, but it's fine. Okay, so now that we've done that, usually the next step in this is to divide by b, divide b by 2 and then square the values. So we have to find out what our new b value is. And our new b value is essentially the second term within our brackets. That's what they refer to as the b. So we're going to put this 12 in here. We're going to divide it by 2, and then we're going to square that value. So 12 divided by 2 is going to give us 6, and then 6 squared is going to give us 36 again. So we're going to add and subtract 36 within these brackets here. So y is equal to 3x squared plus 12x. And the reason we can add 36 and subtract 36 is because adding and subtracting by 36 is essentially adding a 0 to something, so I'm not changing the equation. So I could technically do this to any single equation, but there's a purpose for the reason we're doing this. The next step is to then take out the negative 36 value. You want to take it outside of the brackets. So you only want to have 3 terms inside the brackets, and you want the negative 1 to come out. The problem is when you take out the negative 1, you have to multiply by the coefficient at the front. So because it's a 3 in this case, we're multiplying by that value of 3. So we're going to get y is equal to 3x squared plus 12x plus 36. And then 3 times negative 36 is going to give us 8, 1, negative 108 minus 11. Okay. Now, all of those lovely steps have created something called a perfect square trinomial. Essentially, you're going to factor, and we can go through all the practices of factoring. But the reason we did it this way is so that we could factor very, very simply. We can actually just take the square root of the first and the last term, and we don't have to go through the steps of traditional factoring. So we have 3, the square root of x squared is going to be just the value of x. Okay, so there's only going to be 2 terms after we factor it. The square root of 36 is going to be the value of 6. Because the middle term is a plus, we're going to put an addition here. And essentially what's happening is we're actually getting 2 sets of the brackets that are the exact same, but we don't need to write it that way. We can just write it as 1 to the power of 2. So we're going to write this to the power of 2. This will disappear in a second. And then we just got to equate this final step here. So this is going to be 119, negative 119. So that puts it in vertex form. Now that we have our completed the square, or this is the vertex form. Okay, so we have the vertex form. We can actually pull out the vertex. Because this is positive 6, our vertex is going to be a negative. That's usually called the h value. And our k value here is negative 119, so it's at a negative 119. So pretty far down vertex. The next step would then be to actually go about finding the inverse of this function. So we're going to rewrite this. Y is equal to 3x plus 6 squared minus 119. Okay, and to find the inverse of the function, we're going to essentially flip the x and y value. So we're now looking for x is equal to 3y plus 6 squared minus 119. So within doing this, we want to isolate for y again. So all this becomes is a practice in algebra, so isolating for the variable y. So we're going to look for y. So I'm going to move 119 to the other side. That becomes x plus 119, okay, is equal to 3y plus 6 squared. I need to move this 3 to the other side, and because it's multiplication, it would then become division on this side. So we're then left with x plus 119 over 3 is equal to y plus 6 squared. Now, to get rid of the squared, we find the square root of something, and whatever we do to one side, we do the other. So we technically have the square root of x plus 119 over 3 is equal to, these two essentially, the idea is that they cancel out. We have y plus 6. And then finally, the last step to isolate y, we bring over the positive 6. So our function is x plus 119 over 3, okay, minus 6 is equal to y. Now, in terms of writing the function, this function would now be written as f at x to the power of negative 1 is equal to. Now, if we wanted to actually pull out a k value here, because this is divided by 3, okay, the k value is actually 1 over 3. So I would put a square root here, and I'd have, I'll write it in blue, 1 over 3 times x plus 119. Okay, and then that negative 6 is actually not within the root, it's outside of it, which is really important. Subtract the value of 6. So this is now our inverse function. So let's take a look. We've got our two functions here. Let's actually go about writing them in to see if they end up being inverses. And they're going to be pretty far apart. So 3, positive 6, negative 119. So y equals 3, positive 6, negative 119. So that's obviously going to be very far down. Okay. So here's our one function, and then we, like we said, negative 6, negative 119. And the other one, root a third. So y is equal to root of.
So that point's not going to change because if it goes through y equals x.
Well, that point isn't exactly there. Yeah, from afar, you're right. That looks like it would, but it's not quite at that spot. Here, what do we get? X plus 119. 119 bracket, and we say minus 6. Minus 6. So I'm going to give ourselves a bit of a better scale here because this is hard to see.
And it has to be a function.
Yes, so you'll notice that this didn't draw the bottom part, right?
Why not?
And the reason is because in order to pass the vertical line test, so essentially an inverse function, let's talk about what this is. An inverse function has to be flipped on this lovely dotted line here. This line is essentially y equals x. So I have it as a dotted line, right? It needs to be flipped on there. So in order to be a function, we have to pass a vertical line test. So vertical lines go through our quadratic here. They only touch it once every time, therefore it is a function. If we were to draw the entire inverse, I'm going to do my best here. Ooh, that's not bad. And we were to go the vertical line test, you'll notice it's hitting it twice. So because it's hitting it twice, that means it's not a function. So this program doesn't draw that bottom part here. Now, if your teacher doesn't care if the inverse is a function or not, then the correct way to graph this would be, hey, there he is, would be the actual inverse flipped along that 45-degree line.
Why would you draw the top one and not the bottom one?
Yeah, and you're right. You can
Does it
technically,
matter or no?
it's. I guess you would say it's the mathematical norm is to draw the top version of it.
Yeah, I get that. I was just saying.
Yeah, why don't they do the bottom?
Yeah.
There would be no incorrect way of saying it's just the bottom and not actually drawing the top. I don't know. I'd have to think about it, but I think that's just really the norm. That's why they do it that way. Okay, but does that make sense? The function's all set up there? Okay, good. So let's... Actually, to add to this function here, we can talk about what its domain and range is. And the domain for a quadratic is essentially x is the element of all real numbers. There are no restrictions on this function. The range, however, because the a value is positive here, it's going to be opening upwards. And it's continuous, so y is the element of all real numbers with the restriction that y is greater than and equal to the lowest value, which is negative 119. Okay, so this domain is going to be important come our second function. Our second function here has a domain and range. Now, the range for this function without any function restriction that makes it a function, I know that sounded really weird, but you know with the vertical line test, without restricting the function, then our range is unrestricted, right? So just like our x was unrestricted above, because it's the inverse, the y is now unrestricted. And then our x value, it's continuous, but its domain is now restricted, where x is greater than and equal to anything that is negative 119. So if we take a look, we've essentially switched that with what the range was originally. So let's go over into our function and actually take a look at that. So when we see this here, this is the lowest value of the range, right? And everything is greater than it, so y is greater than or equal to negative 119. And then over here, though we can't really see it, the x value is greater than or equal to negative 119. But with this second function here, so this is our root function, because they didn't draw the bottom part, if we wanted to make sure this was a function, we'd actually have to put a second restriction. The second restriction would have to be y is greater than and equal to whatever the vertex value was. So the vertex value was negative 6. So remember, this was the vertex before, so negative 6 and negative 119. So what that means for our inverse is this coordinate here must be negative 119 and negative 6. So the negative 119 is in the domain restriction. In order to make this a function, y has to be greater than or equal to negative 6. So we actually have to have two restrictions on the inverse function in order for it to actually be a function. Okay, so depending again whether your teacher is going to ask you that information, you might need to know it. So let's